Don't know much about algebra. Don't know what a sliding rule is for. But I do know what it was too. This one could be with you. Oh, this would be.
Hey everybody, welcome back to Mr. K's 30 Minutes of Math. I'm glad to have you all back for another episode. Excited to get started. So let's jump right in. I'm going to pull up our math riddle from yesterday. Here it is, and let me stop the video so I can focus on the riddle. All right, so as you probably recall, we had this interesting diagram which had all these yellow boxes and numbers in them, and the goal was to connect 5 of the numbers by staying on the black lines and get the highest number you could. That is adding all of the squares that you connected. So for example, if you, let's try this, started here at 7 and went to 9, and then 5, and then 4, and then 5, you would have 7 plus 9, which is 16. Then 16 plus 5, which is 21. Then 21 plus 4, which is 25. And then 25 plus 5, which equals 30. So that's the idea. Lots and lots of different ways to kind of approach this. I think trial and error is a pretty good one. I think also you might have realized, let's try to erase this pathway yet, that our largest numbers, 9s, are positioned far apart. So it's challenging somewhat to get them together, but that would be your goal. And then the second highest number we have here is 8. The third highest number we have here is 7. So you might begin to see that somehow connecting these numbers is going to be your best bet to get the highest total. So are we ready? There is the answer, my friends. You'll see if we start here at 7, then go to 9, then to 8, to 6, and then over to 9. Let's add that up. 7 plus 9 equals 16. 16 plus 8 equals 24. 24 plus 6 equals 30. And then 30 plus 9 equals 39. There you have it. I think we have, let's see, let me check the chat. Oh, it's just Aaron saying hi and Oliver saying hi. But if anybody has any questions, feel free to type them in and I will try to keep track of that as well. All right, one thing you might want to try with this is what is the lowest total that you could come up with? What is the lowest total that you can come up with? So I would like folks take just a minute and try to figure out what is the lowest total you can come up with. You can type it into the chat window so I can see if you've got an answer. I'll give you about 30 seconds. Let's get some Jeopardy music. Go. All right, welcome back, everybody. I have not seen anybody type it in. That is okay. That might mean you're working hard to figure that out. Let me give a little bit of a hint. Our lowest number is right here, 2. So we know we'd want to include that. Ah, I see Henry wrote in 22 and Aaron wrote in 17. Interesting. So we have 2 offers so far? Oliver, 2 to 6, then to 5. Now we have 2 ways we could go to 5, but it doesn't matter because they both will take us then to 4. Oh, I see what he was doing. 2 5s. So let me back up like this, to 5, then to 5, then to 4. I think that's what he was going for. And you know what? I believe that is correct. That would give you 10 plus 10 is 20 plus 2 more is 22. But somebody had 17. So if you had 17, can you put in the sequence, the sequence of numbers you had to get 17 so I can try that out? Aaron is telling us, no, it's 17. All right, Aaron, I trust you. Can you type in what your numbers are to get us to 17? By the way, Oliver's solution, it also looks like my sons are on too, yay, and they had the same solution. All right, so Aaron said 2. Let me try to do that. 2 to 6 to 4. So you could go like this to 5. That is great, but that's only 4 numbers. That would give you 17, but that is only 4 numbers. And as you may recall, we had to do 5 numbers. So I do think 22 is it. Great job, everybody. Great job. Fantastic. All right, let us dive in. Real quick on last night's homework, we were going to take these fractions and find equivalent fractions by dividing the numerator and the denominator. And what we're doing, just to remind you what it is we're actually doing, we're going from a small fractional unit like 24ths to a larger fractional unit. A 24th of something is much smaller than, say, an 1/8 of something. So let me do one example here. You could do 3 24ths. We could divide the top and the bottom by 3. Remember, that would be like us getting rid of 3 rows in our diagrams and going down to 1, which would give us 1/8. And so you should have in your mind that a 24th is a much smaller piece than an 1/8 when you're dealing with the same whole, but 3 24ths and 1/8 are exactly the same thing. Excellent. For 2736, can somebody type in what is the number that you would divide both the numerator and the denominator by to help us get an equivalent fraction? And I see Lil Tank wrote in, I think you're saying 9. I love it. So that would be going from 9 rows down to a single row. So 27 divided by 9 is 3. 36 divided by 9 is 4. And there you have it. 3/4 is exactly the same amount as 2736. But remember, again, a 36 is a tiny piece. A 1/4 is a much larger piece. So it takes 27/36 to be the same amount as 3/4. All right, 14/35. Love to see what folks divided by for that one. Can you write it in, please? Oliver tells us 7. I love it, Oliver. Thank you so much. 14 divided by 7 is 2. 35 divided by 7 is 5. 14/35 is the same as 2/5. All right, and then 14/28. Thank you, Lil Tank, for saying good job. I love the positive affirmation. 14/28, Aaron is telling us it becomes 1/2. That's right. What did you divide by, Aaron? Let's see if Aaron can tell us. Oh boy, Harper has all kinds of interesting things to say. Aaron, you divided by 2. Henry says you divided by 4. 14. You can do both. If we divide by 14, we're going to get 1/12. If we divide by 2, then we're going to get 7/14. Now here's the cool thing about fractions. 14/28, 1/12, and I'm sorry, that's not 1/12. Please forgive me for that. 1/2 and 7, whoops, 1/12 and 7/14 are all the exact same thing. And that should make sense because 28ths are tiny, tiny pieces, and we need 14 of them to make a half. A half is a big piece. We only need 1 of them to make a half. And 14ths are kind of in the middle, so we need 7 of them to make a half. All right, great job, everybody. Very proud. I appreciate all of your participation. I'm going to use the whistle for this one. All right, now let's move on. We're going to now show fractions with number lines. This is another way to represent them. And so what we're going to do here, let me highlight this for you. We're going to label each number line with the fractions that are shown on the tape diagram. Then we're going to label first, then circle the fraction that labels the point on the number line that also names the shaded part of the tape diagram. So here's my question, everybody. What should go right here for this first part of the number line? Can you type it in, please? Let's see what folks have to say. What should go there? Yes, 0. Now here's my question for you all. Is 0 the same or different as 0/4? Same or different? Type it in. Same or different? Henry says same. Oliver says hi, Max. Ezra says the same. Lil Tank says same. Awesome. You guys are correct. So here's what I want you to do. Rather than write 0, because we have fourths here we are. There's 1, 2, 3, 4. So we have 4 pieces, so we know we're dealing with fourths. Just to help your brain remember what we're talking about, I want you to write 0/4. Then you can do 1/4, 2/4, 3/4, and then 4/4. 4/4 is the same as 1 whole. And that should make sense because right there, there's your 1 for 1 whole. Cool. And then which one should I circle to show the shaded part? Right here, 1/4. So this is just another way of showing fractions. What we have learned from lots and lots of research is when you show students lots of different ways of representing math, it's more helpful because different people's brains work in different ways. And so whereas a tape diagram might be really great for one student, a number line might be really great for another one. All right, so for B, can you guys type in what is the fractional unit that we're dealing with? Is that halves, fourths, ninths, twelfths? Can you, excuse me, can you type it in? What are we dealing with in B? I see 8. I see the number 8. Eighths. Yes, that is more precise. Eighths. Yes, very good, very good. We're dealing with eighths, and we know that because we have 8 pieces. Here they are. 1, 2, 3, 4, 5, 6, 7, 8. Very good, and 8 equal pieces. All right. So we're going to go ahead and label our number line. We're going to do 0/8, 1/8, 2/8, 3/8, 4/8, 5/8. Oops, oh my gosh. My brain really went crazy there for a second. My apologies. 6/8, 7/8, and then again 8/8. All right, and we have 2 of them shaded. Here they are, 1 and 2, so we're gonna circle 2/8. All right, fantastic. Let's keep going. I would like you to go ahead and create your number lines and label them, and then circle the part the point on the number line that matches the fractions. Go ahead, I'll give you another, maybe I'll give you 2 Jeopardies. Go. right, that was one Jeopardy. Let's give you one more. All right, let's come back. So for A, we have 3 pieces. So what is our fractional unit? Somebody type in 3 pieces. What is the fractional unit? Let's see what folks have. What are thirds? Yes, way to go, Ezra and Donna. Not 3 thirds. Thirds. That's an important difference. Okay, so thirds. We have 0 thirds, 1 third, 2 thirds, 3 thirds. How many of them are shaded? Well, 1, 2. That would be like going from here to here. 2 thirds. All right, B. What is the fractional unit? What is the fractional unit? Let's see what we have, what folks have to say. Anybody? What is sixths? Yes, very good. We have 6 pieces, so we have sixths. So 1, 2, 3, 4 of them are shaded. Remember, we would start here, 0, 6, and make all the way over to 6, 6. And then last, for C, what is the fractional unit? 12ths. Close, very close. That's a hard word to spell. 12ths. 12ths. It's hard because it has that FTHS ending. And we have, let's see, I'm going to start at 0 12ths, but there's a lot to write here. So I'm just going to show it on our number line. 1, 2, 3, 4, 5, 6, 7, 8 12ths. Let me move this down maybe. Whoops, my toolbar is in the way. Oh, there we go, 8 12ths. And all the way over here would be, whoops, 12 12ths for 1. Excellent job. What you'll see, I hope, visually, is look, if I draw a line right here, all of these pieces are the same, 2 thirds, 4 sixths, and 8 12ths. And remember I was talking about all that is changing is the size of the fractional unit. So when we were dealing with thirds, the fractional unit was pretty big. See, these are pretty big pieces. We only need 2 of them to make 2 thirds. When we're dealing with 6, the fractional units are a little bit smaller, so we need 4 of them to make 2 thirds or 4 sixths. And when we're dealing with 12ths, they're kind of tiny now, so we need 8 of them, 8 12ths to make 2 thirds. All right, everybody, let us go. You know what? I'm gonna hold off on this. Let's jump to our math joke of the day. Here we go, friends. Why do plants hate math? Why do plants hate math? Any ideas? I'm gonna give you another Jeopardy to try. What? I thought I was giving you another Jeopardy. Let me try that one more time. Why do plants hate math? Anyone has an idea? Type it in. Okay, I think I like Aaron's answer because they have no brain. That would be funny. Henry, something to do with leaves. No, here it is. Are you ready? Because it gives them square roots. Now, I found this picture on the internet of this tree with a square root. I don't know if that is a real picture or a made-up picture, but I thought it was pretty good, so I wanted to include it. Now, if you are watching today and you're not exactly sure what a square root is, or you've heard about it a little bit, let me explain so you can understand the joke. All right, here is a simple grid with a 10 by 10 grid. And so what I'm going to do is shade some of it. Let's shade a 4 by 4 section. So that would be like this. Okay, so you'll notice it's 4 lengths long. Whoops, I don't want that one. I want this one. It's 4 long. It's right here. 1, 2, 3, 4. And it's 4 tall. 1, 2, 3. Oh my gosh, my brain is really squishy today. 4. So 4 long by 4 wide, which means 4 times 4 gives us how many squares would be there? 16. All right, that is a square when you multiply a number by itself. We talked about this in an earlier lesson. The way we show this in math is with a little 2 up here. Now I want to be clear, that does not mean you do 4 times 2. No. What it means is you do 4 times itself. 4 times itself, which is 16. All right, let's do another one just to make sure we have that well in our minds. Let's do 5. All right. 1, 2, 3, 4, 5. Now I'm going down. 1, 2, 3, 4, 5. All right, so if I shaded all of that in, we would see that we are 5 across and 5 up and down. So thank you, little tank. That would be 25. 5 times 5 equals 25. And we would show that as 5 squared with that little 2. Okay, remember, that's not 5 times 2. No, it's 5 times 5, which would give us 25 squares. And let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Beautiful, it works. Now, that's what a square is. A square root is going backwards. So if I told you that 25 squares were shaded, just like this, and I wanted to know what is the root of 25, that means what number represents the length and the width, you would know it was 5, right? Right here. That's called a square root. It's going backwards. So we show that in math with this funny looking sign. It looks kind of like a division sign when you're doing long division, but a little bit different. It looks like that. That means the square root of 25. The square root of 25 is 5. Okay, let me give you another example to see if we have that in our heads. Take a second and think about the number 36. What would be the square root of 36? Another way of saying that is, what number would I have to multiply by itself to get 36? I see lots of folks writing in 6. 6, very good. Although, Henry, it's not 666. It would just be 6. I think you were just very excited. All right, what would the square root of 81 be? Let's see what we got here. Very good, little tank. 9, because 9 times itself, 9 times 9 is 81. So here is a little chart which shows the squares and the square roots for 2, 3, 4, 5, and 6. So you see here, if we start with 2, this is 2 squared. That's that little notation I talked about, or 2 times 2, which is 4. But if you go the other way, the square root of 4 is 2. Again, if we start here with 3 and then we make our square, 3 squared, which means 3 times 3 is 9. What that also means is the square root of 9 going the other way is 3. Okay, for all of you smarty pants out there, what is the square root of 144? Let's see what folks have. Ooh, Ezra chimed in with 12, and Henry and Oliver, they'll take fantastic, well done. What is the square root of 225? Anybody know that one? Ooh, you guys are doing great. 15, that's right. And it can keep going on and on and on from there. Okay, we have about 4 more minutes. I do want to get back to one more bit of our fractions practice. So now we're going to go back to our number lines, make it a little bit more complicated. Whoops, dropped my pencil. My apologies for that. We're going to create a number line from 1 to 0. So let's do that. Sorry, from 0 to 1. And we want to break it into fifths. That means we need 5 pieces. Okay, so this would be 0 fifths, 1 fifth, 2 fifths, 3 fifths, 4 fifths, and remember 1 is the same as 5 fifths. But then it tells us to decompose 2 fifths into 4 equal lengths. Let me explain what that means. So here's 2 fifths, this part right here. We want to decompose that into 4 equal lengths. Well, right now we have 2 equal lengths, here and here. We want to split it into 4 equal lengths. So I'm going to split up this one and split up this one. So now we have 1, 2, 3, 4. And so my question to you now is, what is the fractional unit that we have over here now? It's no longer fifths. What is it now? Can somebody write in? Oh my gosh, is the screen not moving on? Hold on 1 second, let me double check. Okay, hold on, sorry about all that. Let me re-share it and make sure that we got you set up. That was unfortunate. Seem to be having some minor technical difficulties, my friends. Just hold on 1 second. Let me bring the video back just so I can say hi to everybody. All right, well, I'm just gonna show you. This is what I was doing, 0 fifths to 5 fifths. And as you'll see, I decomposed 2 fifths into 4 equal pieces. And so now those fifths have been turned into tenths, 4 tenths. So what this is showing is on the number line how we would decompose our fractions from 2 fifths into 4 tenths. All right, let me see if I can get the screen sharing back on. Let's try this one more time because we are just about out of time, and I want to make sure that you get your riddle of the day. So let's try that, sharing, and I think it's gonna work. Yay, it works. Yes, I'm very excited. And then just real quick, it says, write a number sentence using multiplication to show what fraction represented on the number line is equivalent to 2 fifths. So that would be like this. Remember, we basically, it's like we created 2 rows in our area diagrams. Here we just broke it up into twice as many pieces. So there we go, we have 4 tenths. And we can go the other way with division, right? We could show 4 tenths divided by 2 equals 2 fifths. All right, to close this out, let me go, here's some homework. If you can take a picture of the screen or do a screen capture, I would love for folks to capture this for discussion tomorrow, very similar to what we just did, but with sixths. Okay, I see a few questions coming in. Let me just make sure. All right, here we go. Here's our riddle for the day. You have two subtraction problems here, but the numbers have been replaced with shapes. You have a blue circle, an orange triangle, a purple square, and a green octagon. Each of these shapes represents a digit. It could be 1, 2, 3, 4, 5, 6, 7, 8, or 9. So each of these is one digit. All of the green octagons are the same digit. All of the orange triangles are the same digit. All of the blue circles are the same digit. And all of the purple squares are the same digit. The question is, what digit goes with each shape to make both of these subtraction problems true? All right, everybody, so take a picture, take a screenshot, try to figure it out. If you got the answer, shoot me an email at jcamrus@rvaschools.net. Have a great afternoon, everybody. Thanks for joining. Bye.